Greetings to all. Welcome back to the course on Introduction to Electric Vehicles. So in this video, we'll be learning about the charging connectors. So what are the charging connectors? What types of charging connectors are available? And with respect to India, which is the connector which is most popularly used? So as we all know that the charging power level and charging connector type are differentiated on the basis of power levels. So there are level 1 charging, level 2 charging and DC charging. So in level 1 AC charging, the rating can be around 1 to 3 kilowatt, and in level 2 charging, the charging can be, the power rating can be between 3 to or 20 kilowatt, roughly 20 kilowatt. And for DC charging, it can go above 200, 300, 400 kilowatt. Even today, most of the chargers which are being targeted by China and Japan, especially a Chaoji charger, this charger is having a rating of 900 kilowatt, so which is a huge power through a charger when we compare a charger and the charging power. So there can be a charging type connector. So every power rating will be associated with some type of connecting chargers. So the connector are the types of male female pins. Means they can be like this can be a charging connector, and there can be 2 pins, 3 pins, 4 pin, 5 pin. So the number of pin decides at which type of charger it is. It can be 5 pin charger, it can be 7 pin charger, it can be only 2 pin charger or 2 or 3 pin charger. Okay, so there are type 1 chargers which are usually used for low ratings. Then there are type 2 chargers, then there are Chedmo, Tesla charger, and there are many types of chargers. So these two are the most common which are being used mostly. So let us talk about the type 1 and the type 2 charger. So this type 1 charger is given by the name which is by the organization IEC. We have already known about this organization IEC and SAE. Okay, so this type 1 charger is also known as J1772 charger, which is the name is given by SAE. Okay, so Society of Automotive Engineers is the SAE full form. So this charger is a 5 pin charger. There are pin number 1 is the line, 2 is the neutral, this is the proximity pin PP, this is protection earthing pin, and this is a control pilot. Okay, so there are 5 pins. A 5 pin charger or the 5 pin charging connector will be known as type 1 connector. Then there is a type 2 connector. Type 2 connector consists of 7 pins. So this will consist of 7 pins and this will consist of 5 pins. So this will contain, it is mostly for the 3-phase circuit. So there are 3 phase 1, 2, 3. This is R phase, Y and B, and this is one for the neutral, and this is for the protection, proximity, and this is for the control pilot. Now what are the role of these 3 pins? So the purpose is to have you might have guessed that these 4-5 pins are very essential and very common. That is, if a 3-phase charger has to be designed, this L1, L2, L3 and neutral have to be there, and this is the earth. So this is the protection earth. So this 5 pin seems to be relevant. What are these 2 pin? We'll be discussing in the next slide. So what is control pin? So control pin is used for mainly communication. This is for the exchange of control signal between the EVSE. What is EVSE? This EVSE is this electric vehicle equipment, the supply equipment, and this is the EV. So the charging, if this is a charger and here is our vehicle, then the connection is like this. So this will be known as EVSE and this is our EV. Okay, so the diagram are very bad. So this is our EVSE to EV communication has to be happen through this CP or the control pilot. This usually happens at 1 kilohertz of square wave, and this square wave communication goes to and fro from EVSE to EV. Now the proximity pin or the plug present pin, the sole purpose of this is to indicate the EVSE that the vehicle is being connected, and this is kind of a protection that only when this connector has been plugged into the EV, then only the power will be supplied. So this tells about the proximity of that vehicle to the EVSE. So this is very important apart from the control pin. Control pin is mostly for the communication. Proximity pin tells only about the proximity of that vehicle to the EVAC. Then there's control signal. This is not used usually. Then proximity detection. These two pins are not used. We are using 1, 2, and 3. And protective earth is a particular. It is a basically earthing. So in our houses also, in our home, when we are using a plug for a single phase, we are using 3 pins. 2 pins for line and neutral, and 1 thicker pin for earth. So it is similar to that. It is a protective earth pin. So in total, apart from the supply line, which can be single phase or 3 phase, we will be having 3 extra pins, and these pins will be PE, CP, and PP. These are the 3 extra pins we will be having. So how we can upgrade this? So as you know that this 5-pin connector, this is a 5-pin connector or the type 1, and this is a type 2 connector. This is type 2, which is 7-pin. Now what happened? These are for especially for the 3 phase, and this is for the single phase. Now what happened? How we can use a DC charger? Now a particular vehicle always have a two options. Either you can charge through AC, or either you can charge through directly DC. So what happened? We need to have some kind of a charging pin which can have both options. So this type of charger is known as combined connector, and this is known as CCS1. So this combines a 5-pin charger of type 1, and this combines a type 2 charger, combines the 7-pin connector with the DC. So this kind of chargers were upgraded to cater for the demand of both kinds of our charging methods. So we can charge our EV through DC also, or DC fast charging, or we can charge it through a AC, through a single phase or the onboard charger which is being kept inside our vehicle. So these two are the options, and to combine these two options we have upgraded our chargers to CCS1 and CCS2. So in India, most of the chargers which are being sold are CCS1 type, which are used at home. So these are the different kind of chargers which are used worldwide in the different markets. So as you can see here, in North America, we are using type 1 charger, and for DC we are using CCS1. So ultimately CCS1 combines this type 1 and also DC charging. Again, in Japan, for DC we use a specific charger known as, this charger is CHAdeMO charger, and this uses only 4 pin. So this is a special type of charger. For AC supply, Japan also use type 1 charger or the 5-pin charger. In European Union, there are used a 7-pin charger or the type 2 charger, and this can be given a different name in different countries. In case of China, China also uses type 1 charger, but they have given it a different name, GBT. And here also for DC they are using a different GBT DC charger. For Tesla, they have a unified charger which is only DC. Tesla do not support, but they are now moving towards the AC charging also. In India, we usually use type 1 charger and type 2 charger, and for DC we are dependent on all these CCS2, CHAdeMO, or GBT from the China. So these are our options which are used worldwide for the different countries, and depending on the rating of power, if if the charger rating is less than 20 kilowatt, then we are going for the AC charging. If it is more than 20 kilowatt or above 100 kilowatt, then we are going for the DC charging. So this is about the Indian charging conditions. So you can see here, in India we are using type 1 and type 2 charger. That type 1 means we are using a 5-pin, or type 2 means we are using 7-pin. So these are the same charger, type 1 or type 2. This is for the summarization, that simply there are 2 AC chargers, 5-pin, 7-pin, and they can be called with a different name in different countries. So what is the future of charging? We cannot have every country will be having a different charging, every company will be having a different charging. So this will be creating a problem. So currently we know that there are CHAdeMO charger, GBT, CHAoji, or CCS charger. So what is happening is, this CHAdeMO is from Japan and this GBT is from China. So what they are doing, they both have collaborated and they are making a unified DC charger which is already coming to market by 2025. So this charger is known as CHAoji, and this is shown here. So this charger is the DC charger which will be uniform through China and Japan. So what will be happening, China and Japan are collectively doing this to make a unified charger. This charger has a capacity of 900 kilowatt, 1500 volt, and can push almost 600 ampere DC to the, so this can charge your vehicle within 10 minutes. So this kind of charging is also available, will be available by 2025. Now CCS, what is the future? The future can be that all this organization combine and can settle at a common unique standard, which you can call CUS, and this standard will be throughout the worldwide, can be common for everyone, which whoever is using it. So this can be uniform throughout the companies and throughout the countries. So this is one of the major problem with the charging connectors. So this is a basic diagram how AC grid is connected to the electric vehicle. So here is a, this is a EV and this is a EVSE. So this is a AC EVSE. So the type of connector we are using can be type 1 and 2. So this is type 1 and 2. This one, the gray portion which I am marking. This currently it is showing type 2 charger, it can be type 1 also. Then there is a DC option. So what happens is you have two options, either you can go through this AC power or you can go through this DC power. So let's take example of AC power. If you are connecting a AC power to this port, this is a EV port and this is a CCS2, this port is CCS2. So when you are connecting this to here, what will happen? This power will be going through this onboard charger and converted to DC. This is AC to DC because you have put a AC charger. So the AC has to be converted into DC and it will be going to the charging unit. Okay. If you are putting a DC charger, which is shown by this red line, then DC charger when connected can directly go to the battery. So this is a battery. Okay. So the red line shows the DC and blue line shows the AC. So if you are going through DC, then DC can directly charge the battery. If you are going through AC, then there is an onboard charger which converts AC into DC and charge the battery. Now this dotted gray line shows the communication through the all the two pins, that is this PP pin and the control pilot pin. So these are the two pins which are doing communication with the charging ECU and this EVSE, both of the EVSE. So these communication can happen with two-way communication is happening, which is telling that charging is going fine and the vehicle is still connected to the EVSE. So what are the challenges? So challenges are mostly at level 1 where uncoordinated charging can happen. Suppose even if in a building there are hundreds people living and the 100 EV are charging at the same time, then there will be load at that building, and similar effect can happen at the grid level also. So this is a problem which can be a problem, especially in the case of peak hours. Like in case of peak hours, if everyone is charging their EV also, then the load on the grid increases. So this can cause a problem. Another problem is coordinated charging. Now suppose every coordination has happened, and coordination is more suitable for high power, while it is beneficial for all overall system load and peak saving and high EV concentration also. That means that currently the EV penetration means the number of people having EVs is less than 5%, even in India also, and worldwide it is around less than 3% of 5%. So what happens if that EV penetration goes to 60%, 70%, then everyone will be having a EV and everyone will be charging, and that can create a problem. So currently the EVs, the number of EVs are less, so the problem is not evident, or the problem is not being shown that much. Then the future problems can be three main: penetration rate, already discussed; the degree of charging, how much power can be taken at one single time is also a problem; and range anxiety is still a problem with the EV charging problem, because it takes a time to charge a EV and that gives a limited range. Even if I charge 5 minutes, then the range I am getting maybe 50 kilometers or 30 kilometers for that 5 minutes of fast charging. So that problem still remains. So these are the challenges which are coming, and you as a aspirant can work towards it during your research or during your work. So in next video we'll be taking a buck converter, we'll be doing a buck converter simulation also, and this will be done using MATLAB Simulink. So thank you for this video.